All right, guys, so today we're going over the review sheet, and your test is tomorrow. So I sent y'all an email letting y'all know that. Hopefully you saw it. So we'll go through all these here and then go on and test tomorrow, and then we'll start Chapter 2. And again, your midterm is mainly going to be over what we've covered on Chapter 2, mainly just kind of a big quiz, and move on from there. So problems 1 through 4 determine which quadrant each angle lies. So again, on the test you can use your unit circle, and that's going to be somewhat helpful, especially for determining quadrants. So if we look at this here, we can do some of each. But one of the biggest, or kind of I find helpful with doing this here, is either one, I didn't mention this in the lessons, but you could go and try to trace around between 0 and 360, kind of adding it up to it. Or you can bring all the angles between 0 and 2 pi, or 0 and 360. You can bring it back to that, so that's kind of easier to determine, especially on the unit circle. Because if we look at 475, well, we can subtract 360 from it, which gives us 115 degrees. Well, 115 degrees is going to be between 90 and 180. So this here is in the second quadrant. I mean, we can do the same thing with negative 374, except instead of subtracting 360, we're going to add 360. And if we add 360 to it, well, we'll get negative 14 degrees. So we can add it again, which gives us 346 degrees, which is in the fourth quadrant. Questions on any of this here? Now we can do the same thing with our radians, 7 pi over 4, and work it that way. Or what you could do is convert it to degrees. Because if I wanted to convert 7 pi over 4 to degrees, in a calculator we can multiply it by 180 over pi. And again, I would use either calculator for this. It'll tell us that it's 315 degrees, which is in quadrant 4. So we could convert it using radians, because we could, well, this one here is just on the unit circle already, so we could use that. Or, so like negative 12 pi over 5, we can continue to add 2 pi to it. And if we added 2 pi to this here, we would get negative 2 pi over 5. Negative 12 pi over 5 plus 2 pi, we get this here. And then again, since it's still negative, we can add 2 pi to it, which would give us 8 pi over 5. And we can see if that's on the unit circle, and well, it's not. It's not a nice angle. So we can look at the fractions and use the 8/5 pi as a decimal to try to see where it works out to be, or we can multiply it by 180 over pi, which is 288 degrees, which is kind of a little bit easier to look at. Because if we look at the unit circle, straight down is 270, which tells us this is in quadrant 4. So sometimes it might be a little bit easier to look at them in degrees instead of radians, because we're a little bit used to using degrees than we are radians, or thinking about a number in degrees over radians. Questions on these here? Yeah. So we could have multiplied this by 180 over pi first. Let's see, you're negative 12 over 5. And get negative 432 degrees. At which point we can add 360 to it, get negative 72. Do it again, and get 288. Or really, if we at least get to between 0 and 360 or 0 and negative 360, it's a little bit, like you could think of it that way, because straight down would be negative 90, straight across is negative 180, straight up would be negative 270, then back over is negative 360. But for the most part, just adding another 360 is not that hard. All right, questions on 5 through 8. So complement, the two angles add up together to be 90 or pi over 2. Supplement is 180 or pi. So if we looked at pi over 3, well, to find the complement, we would subtract pi over 2 from pi over 3. Which gives us pi over 6. And we can do that in the calculator. We can do pi over 2 minus pi over 3. And if you're using the pi, I would use the 30xs because it will keep it in terms of pi. It's not going to force it into a decimal. If you want to use the graphing calculator, you can. And the way we would do it with it is, since we know both terms are going to have pi, we can pull the pi out and just say 1/2 minus 1/3, hit enter and see what we get. Now for 180, or our supplement, we're going to do pi minus pi over 3, which will give us 2 pi over 3. And these here would be our two answers. Questions on this here? Do we want to look at pi over 4? Do we feel comfortable with these here? I mean, with angles, it's the same thing. So for 1, we're going to subtract 90 from it. And for supplement, we're going to subtract 180. 4, 5, which would just give us 44, 134 degrees. Now, it's not always going to work out that we'll have a complement, because depending on the angle, so like 93 degrees, we don't have a complement. Because for us to have an actual angle that adds to 93 to give us 90 would be negative 3. It's not an actual angle that we're going to be concerned with. So it doesn't have a complement, but it does have a supplement, which would be 87, because we're just going to subtract it from 180. Questions on any of this here? Or none? Because I think on the answer key, I just wrote none for complement. Or I think I just wrote none and then 87. Any other questions on 5 or 6? 7 through 10. We can look at 2 of these here. So we'll look at 8. For these here, there's a few, I think I ended up taking off half a point, because in the homework they did the same thing, because we want 2 coterminal angles, 1 positive, 1 negative. We want 1 and 1. And I think some of y'all did give me 2 coterminal angles, but for some of them there was just both positive angles. Because if we look at 498, well, I can subtract 360 degrees from it. And if we do this, 8, 3, 1. So there's one coterminal angle, yes? And we didn't have to add 360 to get it, because we just subtracted 360 to try to get a negative, but it's still positive, yes? So what we can do is take that angle and subtract it again. 2, 2. I believe that should give us negative 222 degrees. Well, now we have one positive and one negative, and that'd be it. So for some, it could be, especially if the angle is already between 0 and 360, to get one positive, one negative, we'll have to add 360 and then subtract 360 from the original angle. Here, since it was bigger than 360, we could subtract it and subtract it. For like negative 375, well, we could add 360 to it, get negative 15, add 360, and then get to 345, I believe. And that would be negative 15 and 345 would be our two angles. And the same thing would work with 37 pi over 2. But instead of adding 360 degrees, we're going to add what? 2 pi. So we can, or not add 2 pi, we'll subtract 2 pi. Because we already have a pretty big angle. 37 pi over 2 minus 2 pi. And that gives us 33 pi over 2. I have one positive coterminal angle, yes? Well, we can subtract 2 pi again. So I could say 33 pi over 2 minus 2 pi. And this gives us 29 pi over 2. So do I have my two angles? No, 29 pi over 2 is still a positive coterminal angle, yes? So what can we do? I can subtract 2 pi again. Which would give us 25 pi over 2. Well, I still don't have one, do I? And again, when I did this and I wrote the key out, and if I was doing this here, again, we're subtracting 2 pi on the calculator, yes? I would keep subtracting 2 pi until I got a negative angle. I would not write, especially for this one here, I would not write it out. Because we had to subtract it once, twice, 3, 4, 5, 6, 7, 8, 9, 10 times. I had to subtract 2 pi 10 times just to get us to a negative angle. I'm not expecting you to write out that subtraction 10 times. And especially in the calculator, if you use the A and S feature, if y'all know what that is, essentially I typed in this one here and then went minus 2 pi. I didn't retype the angle and I just said minus 2 pi, which brought up A and S, and went from there. So it won't take too long for that to pull up. So if we look at this here, and for us, for the graphing calculator, we're going to have to use, it was 37, wasn't it? Over 2 minus 2. I'm taking away pi because it's going to want to approximate it. So we could say enter. And that gave us our first one, yes? Instead of doing alpha y equals 33 over 2, I can do minus 2, which it brings up A and S. And I can hit enter. Minus 2. Clear that out. Minus 2. Minus 2. Minus 2. And I get my answer. Luckily, doing that on the 30XS, if you just, I think I could probably do it here. If I just hit enter, no, yep, because I could keep hitting enter, and it'll keep subtracting 2 from the previous answer. That's also why we've told y'all in previous classes, be careful with A and S, because it's going to grab the previous answer, the last one it gave out. So we have to be a little careful with it, but here it works out nicely so that we could buzz through those pretty quickly, especially for angles that are really big or really small, to get to the answers for these here. Questions on this? 11 through 14, convert from degrees to radians or radians to degrees. To get back to degrees, we multiply radians by 180 over pi. To get to radians, we multiply the degrees by pi over 180. So for 480, we're multiplying it by pi over 180. And again, we can type this straight into the calculator, hit enter, and we get 8 pi over 3. And again, the 30xs is really nice for this because it will take pi into account. If you just want to use the graphing calculator, we would just divide 480 by 180, and it would give us our fraction. And we can go from there and add pi back to it. Questions on going from degrees to radians? So if we want to go from radians to degrees, we're multiplying this by 180 over pi, yes? Well, if the answer already has pi in it, or well, the angle that we have already has pi in it, we really know that those are going to cancel. We can multiply them together. So you can still plug it in as 17 pi over 10 times pi, 180 over pi, and it will give you the answer. But if both of them, if it already has pi, it's going to cancel itself out, and we can solve from there. Questions on any of this here? All right. Going from our angle to degrees, minutes, seconds, or degrees, minutes, seconds back to the angle in decimal form. Now, if we wanted to work this out, what we would need to do for this here is do 47 plus 40 over 60 plus 20 over 3,600. Now, where we get the 3,600 is to get to seconds, we had to take the decimal and divide it by 60. And then we took that decimal and divided it by 60. So the seconds is being divided by 60, or multiplied by 60, sorry. Going from decimal to minutes, seconds, we had to multiply it by 60 twice. Minutes, we multiplied it by it once. Seconds, we did twice. So that means the seconds is going to have to be divided by 60 twice, and 60 times 60 is 3,600. And if we wanted to, we could type that whole thing in just as we have it into the calculator, hit enter, and it would give us the answer. So we do 47 plus 40 over 60 plus 20 over 3,600. And it's not too nice of a number because we get 47.672 repeated. Now the graphing calculator, 47, we can go second apps and say degrees. And then I think it was 40 minutes, 20 seconds. Then we could go 40 second apps. And the first one down is minutes, 20. Now, seconds, we have to pull up the catalog and scroll up a few and do this here. Same answer. It gives it to us. So we could do it in either way. It's just whichever way you remember how to do it. If you forget how to plug it in, we can do the divided by 60 for the minutes, divided by 3,600 for the seconds, and we get our answer. And going from degrees, minutes, seconds with the decimal, we take the decimal number and multiply it by 60. And then take that decimal number and multiply it by 60. Or 97.8375. Now, where we got the degree measure and minute measure, down at the fourth one is DMS, degrees, minutes, seconds. So if we hit enter after typing that in, enter again, there's the answer. So it'll do it for us, degrees, minutes, seconds. Any questions on this here? We good with 15 through 18? 19 or 20, which one do we want to look at? Do you have a preference between 19 and 20? So give it a point. So they gave us these points here, yes? And it's a little bit nice because they gave it to us as a fraction, not as a single number, which some of the ones later will. And on the unit circle, we said that each of the points came in the form of cosine comma sine, yes? So that's telling me cosine of whatever this angle is cosine of theta is negative 8 over 17, yes? Sine of theta is 15 over 17. Because we could have set a triangle up. Because negative x, positive y is going to be here. And we're going to be at this point, negative 8, comma 17, comma 15, 17. And we could have worked it from here. And it does scale back out, because we could say that negative 8, 15, 17 is the triangle to get it back and work it back out, and we would get the same answers. Now, tangent of our angle, we could divide. If we didn't set the triangle up, we could have plugged these into the calculator and divided it, sine over cosine. So 15 over 17 divided by negative 8 over 17, which gives us negative 15 over 8, opposite over adjacent. Now we also need cosecant, secant, and cotangent. But once we have sine, cosine, tangent, secant, cosecant, and cotangent aren't that far behind. Because cosecant's 1 over sine, so that'd be 17 over 15. Secant's 1 over cosine, so negative 17 over 8. And cotangent's 1 over tangent, so negative 8 over 15. And that's it there. Questions on any of this here? We ready for the next one? Now 21 through 24 are not too bad. Now 21, 22, 23, or 24, is there one of those in particular that y'all want to look at? Now if we look at 5 pi over 6, It'd be nice if it's on the unit circle, because if it is, it kind of gives us the answers. And if we look at this here, well, 5 pi over 6 is on the unit circle. And sine is our x value. Or sorry, not x value, y value on the unit circle. So on the unit circle, if we look at 5 pi over 6, it tells us that this is 1/2. Cosine. Cosine of 5 pi over 6 is negative square root 3 over 2. And at this point here, we would do sine over cosine. If we could plug that into the calculator, we don't have to do that by hand, and we would get negative square root 3 over 3. And again, with most of these square roots or plugging these in, I would use the 30xs. Because it's nice, it does a good number of things, but it works a little bit better on this here than the graphing calculator does. And again, for sine, cosine, and tangent, we're just flipping it. And out of these three, sine's the easiest one to flip, because if we flip 1/2, we get 2. Now for our cosecant and tangent, we've got to flip these here. So it'd be negative 2 over the square root of 3, or negative 3 over the square root of 3. And again, we could plug these into the 30xs and have it rationalize the denominator for us. We don't have to go through that process. And it's going to tell us it's negative 2 square root of 3 over 3. And here, we're just going to get negative square root of 3. Any other questions on 21? Do we feel good about 21? Y'all want to look at 22 or 24? Doesn't matter. 24. Now 24 is a little bit different because we don't have a positive angle, we have a negative, yes? And on the unit circle, well, we can see where 120 is. 90 in the first one, so we would actually be at 240. Another way we can get to it is adding 360, which tells us its coterminal angle is 240 degrees. So the values that negative 120 have are going to be the exact same as 240. So here, sine of negative 120, I can look at 240, which is negative square root 3 over 2. Cosine of negative 120 is negative 1/2. And tangent of negative 120 is going to be our square root 3. We get this here, and it'd be positive. In the 30xs, try typing in tangent of negative 120 and see what you get on the 30xs. And I would make sure that it's in degrees, not radians. We'll do these just fine. And then we could flip them and type them in still, which would mean negative square root 3 over 2 is going to become negative 2 square root 3 over 3 -2, and then square root 3 over 3. And again, at this point, we're just mainly typing those back in. So for cosecant, we would do 2 over square, or -2 over square root of 3, hit enter and have it rationalize. For secant, we can do this here, or for cosecant, secant, and cotangent, because cosecant we know is 1 over sine, yes? So I mean, I could type 1 over sine of -120 in the 30xs, hit enter, and it should give you -2 square root 3 over 3. If it gives you a decimal, that button right above enter, the 2 arrows, will approximate it back into our angle. Does that make sense? Any other questions on 21 through 24? Yes. Try, well, in the graphing calculator, it's still going to give you a decimal. In the 30xs, because we've gone over how to convert it from degrees to radians. So if you go mode and bump over on the first one to radians, hit enter, and then clear, should get you back out of it. Type in sine of -5 pi over 3. And see if it gives you square root 3 over 2. That's the nice thing with these calculators. So we've gotten to a point where the calculators can do it for us. The unit circle and a lot of the stuff we're going to go over was very nice when we didn't have this technology to actually do these here. We had to do these calculations by hand. Questions on any of this here? Any questions on 25 through 32? We good with these here? Because most of these here are not too bad. I mean, for tangent, you can type in tangent of 0.6 degrees. So we'll need to make sure the calculator's in degrees. For 25, 26, you'll need to make sure it's in degrees. 27 and 28, you'll need to make sure it's back into radians. 29 and 30, you're back to degrees. 31 and 32, you're back to radians. And for secant, well, that's 1 over cosine. So we could type it in as 1 over cosine of 47.2 degrees, which is 1.4718. So you'll want to round to the 4th decimal place. Now for 27, sine of 3 pi is 0. You don't have to, I'm not going to count off if you don't write 0.0000. I'll just take 0. If it comes out as like the square root 3 over 2 or 2 square root 3 over 3, any of those, just approximate it to a decimal, round to 4 places. Questions on this here? I think y'all like these, where you're just converting it to a decimal. These are all you just type into the calculator and go from there. We good with 25 through 32? Okay. It seems I lost 33 and 34, but I believe 35 is just like those two. Yes? Given a trig expression and theta is an acute angle, find the 5 other trig angles. So because it told us theta is acute, it means we're in quadrant 1. We're going to be in quadrant 1. Now they tell us cosecant of theta is 25 over 7, yes? What does cosecant line up with? Sine of theta, yes? We just flip it, don't we? Now we just need to find cosine, tangent, secant, and cotangent of theta. We just need to find these other 5, or other 4. Now, given that this is the angle, sine is what over what? Opposite over hypotenuse. So our opposite side would be 7, the hypotenuse would be 25, yes? So the only thing we're missing is the adjacent side. So the adjacent side, we can say plus 7 squared is equal to 25 squared, yes? Or we're saying that b squared is equal to 25 squared minus 7 squared. Or realistically, that b is the square root of 25 squared minus 7 squared. And we could type that all into the calculator. We could have done that out step by step, saying that b squared plus 49 is equal to 25 squared, which I think is 625, but I'm not. Yep, 625. Subtract the 2 to get 24, I believe. Yep. So our adjacent side's 24. Now we can use the opposite, adjacent, and hypotenuse to find the rest. So cosine is adjacent over hypotenuse. 24 over 25. Tangent's opposite over adjacent. 7 over 24. Cotangent's just the flip of tangent, so it's 24 over 7. And secant is the flip of cosine, so 25 over 24. So really with these here, once we find sine, cosine, and tangent, we have the others. Any other questions on these here? You all feel comfortable with 33 and 34? I'm going to try to keep these as Pythagorean triples for us, especially on the test, so you're not dealing with the square root of some funky number and are having to go back and use the TI-30XS to figure out what that radical is and working to get it. Questions on 36 or 37, one of those two. Let's look at 36, because I think 37 was funky. Yeah, 37 we had to approximate the decimal because the square root didn't work out nice. Now for 36, negative 410. Try it again. Plot the point. So the x value is our negative 4. Our y value is 10. I'm going to go on and plot that point to see where we're at. One, it does help us figure out what the values are going to be with sine and cosine, with our signs, positive and negative. Now to find the hypotenuse, it's just going to be the square root of a squared plus b squared, yes? Now in the calculator for this one here, I don't plug in parentheses negative 4 close parentheses squared, because we know this number is going to come out positive, yes? So we could really take the square root of 4 squared plus 10 squared to get the answer for this here. Which actually comes out to be the square root of 29. Because 4 squared is 16 plus 10 squared. I think this is not the right answer. Second square root. 2 squared of 29. So the hypotenuse is 2 square root of 29 is our hypotenuse. So for sine of theta, we have opposite over the hypotenuse. Bless you. And at this point here, we can go on and rationalize that. We can type it into the yellow calculator and get 5 square root of 29 over 29. Cosine is going to be our negative 4 over 2 square root of 29, which will give us negative 2. Well, and if we type this into the yellow calculator, yeah, we'll get negative 2 square root of 29 over 29. And lastly, tangent of theta, oddly enough, is negative 10 over 4, which is negative 5 over 2. Out of all of them, that's the one that worked out to be the nicest out of the group. If you want to have it cosecant then secant, that's fine, especially if you're trying to make sure that you keep sines together, cosines together. Now, the easiest one out of the group is cotangent, because it's going to be negative 2/5. And the reason I say that is because, well, sine and cosine, if we flip it, if we flip these here, well, we got the radical back in the bottom of the fraction. We've got to rationalize it again, yes? Well, what did both of these start out as? So for sine, it was 10 over 2 squared root of 29, yes? 10 over 2 reduces to 5 over 1, yes? And if we flip that, well, this here would be the square root of 29 over 5. But it is perfectly all right to plug it in as 29 over 5 square root of 29. To flip that fraction, hit enter, and the calculator will simplify it for us. The same thing with cosine, which is going to give us negative square root 29 over 2. Well, not that 4. We get this here. Any questions on any of these here? We good with 36 and 37? Let's look at 38 and 39. Is 38 or 39 one of those in particular that y'all want to look at? So we could look at 39. Secant of theta is 17 over 8. Well, secant's the same as what? 1 over cosine, yes? So really what this has told us already is that cosine of whatever theta is going to be 8 over 17, yes? And since sine is less than 0, well, we know sine is negative, which kind of tells us which quadrant we're in, which is quadrant. So your sine's negative, cosine is positive, is quadrant 4. So we're down here is where we're at. Opposite is 8, tangent is 17. And again, we can use our Pythagorean theorem. Sorry, this is 8, and this works out to be 15. Now the sign's going to be negative because, again, we're in the negative axis, x-axis, or not negative x-axis, negative y-axis. Now sine of theta is going to be negative 15 over 17. Tangent of theta, opposite over adjacent. We already have secant, yes? So we don't need it. We need cosecant of theta, which is just flipping sine's value. And cotangent of theta is going to be negative 8 over 15. Questions on 38 or 39? No? We'll go on and finish this tomorrow. I'm not going to make y'all stay too far after this.